Thanks for joining us. We are going to talk to a scientific glassblower at Yale University, Darrell Smith. Thanks so much. When I first came across an article about you, I thought scientific glass blowing at Yale, and there's a lab in the Department of Chemistry. Who knew? So, how did you end up doing this?
At Yale, or
just from the very start?
From the very beginning.
You were a fish farmer, right? Or you were going to go into that?
Yeah, technically, yeah. Okay. I got my undergraduate degree in fishery science, and this is way back in the early '80s. I had worked in a biology lab for about a year, and realized that I needed to either advance my career in that field, or maybe try something different. I had read an article in the Sunday paper about a school in southern New Jersey that teaches scientific glassblowing as a 2-year Associate of Applied Science degree. I looked into that. I did a little bit of research, just didn't jump into it right away. Well, back then you didn't go on the internet and research it, so I made some phone calls.
You had to get a book and look stuff up, right?
Yeah, I talked to relatives that were and talked to my brother who was at Rutgers. My father worked at he worked at the RCA plant, and at one time they had a glass blower there, and they both told me that it was an essential part of the support of sciences.
Sure, absolutely.
So I thought, okay, well, let me give this a try.
Had you had any background at all?
None.
Because, where do you start? So.
Well, it does have the aspect of working with your hands.
Sure.
And as well as the science that you need to be able to build this kind of apparatus. So all that kind of stuff, it all seemed to kind of come together. So I gave it a try. I went to the school, and I was able to go through the program kind of easily because I didn't have to have all the other course requirements. So I just concentrated on the glass. And so with that experience, I got a part-time job working in Southeast Pennsylvania, a small glass shop, and that led to working full-time. Then,
and how long have you been at Yale?
Have been, since 2005.
So a long time.
Right.
All right.
So, but going back there now, so I worked in the industry for about 15 years. Worked in manufacturing, some large manufacturing plants in South Jersey. In 2000, the instructor at the school retired. So I applied for it and got his job. So I was, from 2000 to 2005, I was teaching people to be scientific glass blowers at that school.
Wow. And then Yale found you.
Yeah. Although Yale, they were putting a lot of money in the sciences. They had recently built the Chemical Research Building, CRB, in 2005, and they wanted to have somebody here full-time, so boom.
Let's look at a video that you sent to me about what this looks like when you are blowing glass. Now, this is in the Department of Chemistry.
Right.
And what are we seeing going on here?
Well, what we're watching here is my trainee, Preston. He is putting together some component parts that we have. It's a round-bottom flask, and these are purchased, as well as these joints, and these are tooled. So I purchased these, and I'm really fabricating from these parts. So in that video, he's taking off the excess tubing off this flask and sealing on what we call the outer joint.
And is this just there's no pattern here, so you kind of have to feel your way through this as you do this?
Well, there's a certain process. There's a certain position where you have to place the torch so that and he's fire cutting. So he's heating that and pulling it thin and fire cutting the two component parts, and then he fuses them together.
And these are going to go in labs at Yale?
Well, that's the one part of it. The second part of the video, and I hope it's there, there he's finished with that, and that is the two parts sealed together. Mm-hmm. The second part of the video is taking another component part, the inner part called the inner joint, and that's doing it on the bench. And I'm going to I'm going to push up a Maria on that, a ring of glass, and then I'm going to round it off and put some holes in that, and then you'll see later on where that part gets fused together with the part that Preston made. So
do scientists come to you and say, hey, I need X, Y, and Z, and you make it for them?
Sure. Yeah. It's the researchers come. This particular item it's kind of a standard apparatus. Mm-hmm. So they may just, I just get an email or phone call saying, hey, can I get that piece of apparatus? Sometimes they come with some modification of a pre-existing type of apparatus that I'm familiar with, and sometimes they come with completely new designs. And
you're looking it up. Do you basically work with a torch? Is that how this is done?
Yes, you work with, it's a gas oxygen torch. You'll see valves on there that I can adjust to get different size and temperature of flames. very thin or very broad, depending on what I need to do. There I am, it's pulling out the hole so that I can insert the...
It's really neat looking.
You should see it in person.
What do you do with the scrap of glass? Can you remelt it? And
no, that's been a common question and common discussion in a professional society, what you do with it. It's really, you can't mix it with other types of glass. The manufacturers of glass, they do use what it's called cullet, that's scrap glass. They generate enough of their own cullet. And actually, it's like 30% of new glassware glassware consists about 30% of cullet or used glass.
Oh, okay.
And they generate enough of their own. But the only thing that I know that this can be reused for is they take the glass and they crush it up and they'll mix it with road paint. And that's what's the lines on the road, what makes them glitter with the headlights.
All right, which is a safety thing.
Yeah,
all right, let's go through all of this. And let's start with this. You want to start here or down here? Might as well start down here.
Okay, start down here. Yeah. So we saw in the video taking these component parts, this, and this flask, and making this, a bump trap, right? So you see there's...
And you're etching on the bottom.
This is ground. Okay. This is done by another manufacturer so that they fit. Okay. They're airtight, liquid tight, so it'll hook up to other pieces of apparatus. Right. And it can be quite extensive. So this is just made so that it's a bump trap. When they're boiling a liquid, it bumps. You never see it and splash. Yeah. So what comes up here is like liquid and air, and it rises up through there, but it pops that stuff.
Do you ever think about being a scientist as you're doing all this, and you get to know?
Well, you're supporting science, so I don't. They'll come in with questions sometimes, and it's a real kick because they'll come in with I have this process I need to do. I have this experiment I need to do. And I say, okay, let's just talk about what you need. And they tell me all the stuff that they're going to do with it. And it's going way over my head. And I have to kind of like refocus their thought pattern, energy. So, okay, no. Okay, I know you want to
boil something.
You want to boil, that's that's very simple, but they want to do some catalyst reaction, and it's like, okay, well, let's talk about what the design is going to look like. You want to put something in, you want to take something out. It's going to be pressure, what kind of temperature, and so I get them focused on the physical aspects of the apparatus. So interesting. Yeah. So that's that.
Got this little gem here.
Right. Now that's just to show a component part. I'll buy this and use this to build. This is a schlenk line.
Of course it is.
A schlenk vacuum line. Okay.
Which it looks like a musical instrument to me, and you said yes.
They do make musical instruments out of glass, but I don't play, so.
So liquid is going to go through here?
No.
Oh, really?
No. Okay, so this is used like, so
that's why I'm not a glass blower.
Okay, well, do you want to be?
No, I got enough jobs.
Okay. Anyway, so this is a schlenk line. Okay, so this lower portion here, it pulls a vacuum. So the vacuum gets pulled on there, and then of course the vacuum pump is hooked to this right here. And then it just traps out any impurities, water vapor, so it doesn't get in your vacuum pump. Now, what this is, you pull a vacuum on it, you can connect vessels onto the portion down here.
Oh, okay.
Okay, so, and it's used a lot in the chem labs. And the way I'd like to describe it is, there's a lot of chemical reactions that won't take place in the presence of oxygen or in the presence of water, or that just won't occur. So they put a vessel on here and they create an atmosphere that will allow that chemical reaction to take place. So they can pull a vacuum on it, and then they can open it up and put in an inert gas such as argon or nitrogen. So they create an atmosphere where this chemical reaction can take place. So it's used, it's pretty much a workhorse in some branches of chemistry. They use these quite a bit, like every lab has them.
How long does it take you to make one of those?
Oh, this will take about anywhere 7, 8 hours.
Oh my gosh.
Put it together.
Labor intensive.
It's just a day's work.
Just a day's work. Okay, what is this?
Okay, now this is, for short term, it's a bioreactor. And they use it, the med school research labs use these. Now it started out with a simple version like this. So this is a piece of rubber tubing inside. And that just represents like the body tissue that they would be using in here. So they have these other tubes, and they'll put a nutrient in there, and they can flow something through there. So in this case, they can flow through inside the tube and flow outside the tube, and they grow these vessels.
And are you blowing this part too? So,
well,
it's just a piece of glass and you break it off?
Well, it's a piece of tubing.
Okay.
Okay, so this is, I think it's, you know, a certain dimension. You know, in my stock room, I have all the tubing that I need. They come in 4 and 5 foot lengths. So, and they come from very small to, you know, very, very, you know, I can give the numbers, you know, like 2 millimeters OD up to 150, even larger, you know, 6-inch diameter tubing and everything in between. So, you know, so for this vast array of different size tubing and component parts, yes, you know, I'll build this. And the screw threads too, I buy these from a manufacturer with these fittings and I fabricate from that.
To make it work. Right.
So they grow these now. I started out with a version like this, and it started getting bigger and bigger up to a version like this, and it was, finally I had to ask the researcher, okay, what are you doing with these?
It looks like a horseshoe.
And he told me,
here.
yeah, that's a horseshoe clamp, but he said they're growing these vessels, and I think they start with a pig vein, and then they wash off all the cells off the pig vein and leave this collagen structure. And this collagen structure is, it's like cartilage. It's the same for all mammals. And you know, I hope I'm getting the salt right.
Oh, it's
somebody's
close enough.
Oh, yeah, well, yeah. And then, so they can stock these. And then when somebody needs a graft or something in their veins or heart, they can just take it off the shelf.
Oh, they're growing tissue in here.
They can grow their own. They can take a blood draw from a patient and grow it, and it's their own.
Amazing.
And you know, it's not robbing Peter to pay Paul, like taking something from another part of the body. It's your own, and it's not a donor. Yeah, and it was like really cool.
Now in science we use clear glass, but you've got something that's green glass, and
yes,
it looks kind of like a pickle. I said, but that's not what it is at all. What is this?
This represents a gallbladder.
Of course it does.
Right, and this was part of a project that I was asked to work on. With the New Haven Arts Council, as a reintegration project. It was back in 2013, and I had a med student came over, and she had the idea is to make a glass gallbladder, and we were going to set them up in a display. Now gallbladders are in Western medicine, they're considered like disposable. You have infected or something's wrong with them, just cut them out, throw them away. Whereas maybe in Eastern medicine, they try to treat it and keep it. Okay, so the idea was to take not just one of these. I made like 100 of these, and we tied them to fishing line and we hung them up on a canopy and hung them up so they're all hanging down, and put them up on the display. And we had a reception where people, you know, for a donation, whatever they felt like they could give, they could take a gallbladder, and they would go up and they would give them scissors.
And that becomes a Christmas tree ornament. Maybe.
Sure. And so they would, and so in replace to that, we would take a Polaroid picture of them, and they would write on the back why they were taking that gallbladder, and that Polaroid picture would replace the spot where the gallbladder was. And it was kind of like a neat just to see the writings on the back and see, you know, the stories behind there about like somebody's loved one had their gallbladder removed and how hard it was. And so that was a real interesting project. But it came out good because you don't have the vast color palette in glass. You don't have any, you know, so you only have certain colors. And luckily, I was able to find
So did you mix this to get green, or did it come green?
It came green.
Okay. So when you, at the end of the day, and you told me you start very early in the morning because you need your, you know, the full brain on power and a cup of coffee probably to do this.
Yeah, just like anybody. But
did you ever think you would end up doing this as a career?
Not before I got into it. When I got into it, yes. I mean, I knew I started into it, and it was like, you know, you make a career change, and it's do or die. I mean, you just go into it, and you know, I was starting family, you know, I was starting to have kids, and it's like, okay, let's make a go of it, and let's get on it.
So there's two folks. There's you and an apprentice in the glass blowing lab.
Very well. He's trainee. Yeah.
Okay, trainee.
I'm very proud that Yale allowed me to hire somebody because things got so busy for me. There's several glass blowers. UConn used to have a glass blower. He had to leave, so I've got all the work from UConn, and they do work for all these other universities just start coming in. How
rare are you? I mean, are there only dozens of scientific glass blowers?
There's hundreds, maybe 400. It's hard to say.
How many things do you make a day?
Oh, it can be very, I mean, That can vary depending on the complexity. I mean,
sure.
You can make 10 of these and make maybe only 1 or 2 of these. You can make 3 or 4 of those. It all depends. The day is not really spent just making things all the time. And so a lot of time is spent, consulting. Somebody comes in and they have a question, and you have grad students coming in all the time. It's a constant turnover. So they come in, they're kind of new. So you have to teach them, what's available to them when they want to make a new design.
Sure.
And all that sort of stuff. And so there's a lot of time spent.
You mentioned the Smithsonian.
Educating people.
Did you do some teaching at the Smithsonian, or you
oh no,
showed off the glassware?
I gave a presentation at the Smithsonian, but I do also teach a course at Yale. It's a graduate level course. It's alphabet every semester, and I have 5 students that come in, and I show some basic projects. They start from the very beginning, and their final project is a hero's engine. Which is? Hero is a Greek inventor, and if you can YouTube it, I have it on my website. I could have brought one. Sorry about that. But and here was a Greek inventor. It's an early kind of steam engine. So you have a bulb like this, and you have a piece of tubing coming out either side, and then you have these tubes coming out on the side that are bent with little pinholes in it. You fill it with water, and then you put on rollers, and then the steam generates and goes out the orifice, and it starts to spin. So they have to prove themselves. You have to make it balanced, yet and true, and yeah.
What is rewarding about what you're doing?
Well, it's rewarding that here at Yale, working in research. For years I built things like this. And in manufacturing, you box it up, you send it out, you never hear anything. But being directly in contact with the researchers, I can make something, and I have made things, and they'll take it to their lab. It'll be a new design, and they'll run it up there, and they'll try it, and they'll come back the next day and say, it didn't quite work right. Can we make this adjustment? And no problem. And sometimes they're in a rush. Things like, they have to get this compound made because it has to run through this test instrument, and they have to send it out somewhere, and they have to schedule that time, so they got to get this made so they can get their scheduled time on this test instrument, or they have to get this made because there's a grant review process and there's somebody going to be checking on it. So sometimes they're really
you're troubleshooting for them a lot.
Oh yeah, absolutely.
And they owe you when you do that.
Well, they do. I mean, they come by and they'll come give me a cupcake every once in a while.
Well, there you go.
Do some nice things, but it's rewarding to come back. You get that feedback right away. They'll come back, and the researchers come back. Oh, I got some really good data from that, and they'll show me. I'm like, oh, it's a nice looking chart. I don't really understand it,
right.
But they'll be, and it's like you get that feedback right away.
But you made their day.
Yes.
Darrell, I want to thank you so much for enlightening us on scientific glass blowing, because
Certainly.
As I said to you, who knew? And here it is. It's a whole career.
Yes, it is. It's a very satisfying career.
Thank you so much.
Well, thank you, Anne.
Spend all night kissing, and if one was right here, then who else is missing? Got a little sidetracked to find myself wishing I could find the keys to the door, but it's also a metaphor. Things keep locked in the grocery store, but mine just the same time. Skip right ahead to the last ride.